Hello, I want to review with you the three types of rocks that you have been studying in science and the rock cycle. So there are three types of rocks that you have learned about: igneous, sedimentary, and metamorphic. So knowing these three types of rocks, it will allow us to understand more of the history of the Earth. And there's kind of a cool rock cycle that shows arrows over here. You're welcome to pause and kind of check it out. Let's look at igneous rocks first and how they are formed. Remember that igneous rocks are formed by melting, cooling, or crystallization of other rocks. So they're not just made under the ground like some. They're formed as a result of a volcanic activity, hotspots, and melting that occurs underneath the Earth's surface. So here are some great pictures showing how igneous rocks are formed. Igneous rocks are common along plate boundaries or mantle hotspots. So here you can see a picture of mountains, water. It does show us a picture of different layers of the Earth down here, the different plates, and you see the little stars where igneous rocks are formed. Igneous rocks are classified using texture. We describe it as glassy, no visible crystals, or the fancy word aphanitic. Phaneritic means visible crystals, or porphyritic, some visible and not visible crystals. So these are all pictures of different igneous rocks according to their texture. Crystal size is also used to classify igneous rocks, and we have a lot of igneous rocks in Wyoming. Crystals form as the rock cools, and the crystal size can tell us a lot about the cooling history. The larger the crystal, the slower it cooled. So that's kind of cool. Igneous rock's texture sometimes is glassy. There's no crystal structure at all. It was probably formed by cooling off really, really fast, such as surface of a lava or when lava enters the water. So I think these are really pretty black igneous glassy rocks. Igneous rocks, aphanitic rocks, have no visible crystals. They are probably formed by fast cooling above the ground, and they're kind of dull compared to the last rock we saw. Igneous rocks, phaneritic, that have visible crystals, they were probably formed by slow cooling below the ground. So different paces of cooling has a lot to do with the texture of the igneous rocks. Porphyritic rocks have both visible and non-visible crystals. They were probably formed by two different cooling events. So we see a pretty different variety between these two. And then igneous rocks, if they're dark, they're formed by basaltic or mafic magma because it might have a lot of magnesium in it. The magma that forms these rocks is usually very hot, around 1,000 degrees Celsius, and has some viscosity, which means it's pretty, they are describing it as ketchup, and you can see the comparison of the rock next to a penny. Viscosity, we're going to have to look that word up and describe it in other forms other than rocks. Igneous rocks that are light, they were formed in high silica content. They're silicic or felsic magma. The magma that forms these rocks is usually more cool, a lot less than 1,000 degrees like we saw in the last slide, 850 degrees. And not quite as thick, not quite like ketchup, a little thicker like peanut butter. So that's interesting. And here's some cool pictures showing igneous rocks and the formations of them. We see all the layers where the magma comes up under the mantle, and many different kinds of igneous rocks. Examples of igneous rocks that we saw in this unit: basalt and granite were the most popular. You can also see on this list we have rhyolite, andesite, diorite, and gabbro. So the history, if you find igneous rocks, you know a little bit about the history of the Earth, where igneous rocks are. Let's move to sedimentary. Sedimentary rocks are formed by weathering, erosion, deposition, and compaction or cementation of other rocks. Sedimentary rocks form in areas where water, wind, gravity, deposits sediment. So a lot of sediment compacted. Sedimentary rocks are likely to form in deltas, beaches, rivers, glaciers, sand dunes, shallow seas, and deep oceans. Sedimentary rocks are classified into two groups, either clastic or chemically formed. And we talked about chemically formed sedimentary rocks last week, the chemical changes. So sedimentary rocks are clastic if they're made of pieces of other rock that have weathered and eroded. Clastic rocks are grouped based on the size of grain that they're made of. So these are pretty cool sedimentary rocks. We also see very small particles make up a mud rock. Medium-sized particles make up sandstone. Large particles make conglomerates. So I like the examples they show us of those different kinds. Sedimentary rocks that form from chemical process are biochemical or chemical precipitates. So they may be in shallow lakes or seas, and they're fossils, really. So sedimentary rock formation, we can see the layers even on a hillside sometimes. They include stratification, cross-bedding, graded bedding, ripple marks, mud cracks, and fossils. Some of the most common types of sedimentary rock are conglomerate, sandstone, shale, limestone, gypsum, oolites, and chert. And some of these we did not read in our unit, but if you come across them in the future, you know they're part of sandstone. So sandstone is where a lot of fossils are found, and that's pretty cool. We have a lot of fossils in Wyoming. Metamorphic rock is formed by heat and pressure, changing one type of rock into another type of rock. Metamorphic rock is from lava intrusions that provide heat, and then these small areas of metamorphic rock form from contact with metamorphosis. So it goes through metamorphosis from the heat going into different layers of the earth. Shows us here that rocks that go through metamorphose, there's increasing heat and pressure, and that forms large areas of metamorphic rock. Classification is foliated or non-foliated. Two major groups of metamorphic rocks. Foliated means there are different pressures that cause the mineral to form layers. These rocks have stripes or planes that break easily along those planes. These stripes don't usually line up with the original bedding planes like the sedimentary rocks do. Metamorphic rocks that are non-foliated are formed in areas where pressure from all sides was equal, so there was no linear quality to the rock, a little bit different. Metamorphic rock formations where there's folding, stretching, dark and light layers. We see some of that in the hillsides near the mountains. Metamorphic rock examples might be slate, schist, gneiss. We've read about those in this unit. Amphibolite, marble, quartzite, and metaconglomerate. So metamorphic rocks, you see them on the chart here. The intensity of metamorphism, it shows a lot of the arrows. You can press pause and study the chart a little bit. It also shows, depending on the layer and how deep or how close to the heat, different kinds of metamorphic rock. So looking at these three helps us review the different kind of rocks that you have learned about in Unit 2 in science. Thank you for watching.